Forgot, huh? No problem. Okay, so when we talk about matching with single character file or directories, star means represents everything. Okay, more than one character. It may be one character, two character, 10 character, or whatever it is you can find. Square brackets is nothing but it is going to check the range. Now the question here is how it is going to work. So let me log into the machine and let me show you how it is going to work. So you can see here. So I'm having some files and directories here. So let me give you a detailed information how it is going to work. So I'm going to say ls question mark. It is going to give you the files and directories which starts, which is just single character naming convention. And if I put double question mark, it is going to give you single character naming convention. This is nothing but directories. And when I put double question mark, it is going to give you, if I put 4, it is going to give you like this. Right? So this is the way how it is going to, right? And you can also search like this. What is that? Oh, even this also will work. So I'm saying my file or directory which starts with O, and I don't know what were the other naming convention, it is going to give you that. Okay, so this is the way how you are going to use this question mark. Now when I talk about star, so what is the purpose of star? When I say ls star, star means everything. Star means everything here, right? So when I say everything here, and apart from this, if you want to search, for example, ls, I just want to go to the etc and I want to search for a file or a directory. I mean, I want to search for a file which ends with .conf config file. So it is going to give you like this. Okay, so this is how this star is going to work. Okay, and we have something called range. When I talk about range, for example, ls, I'm going to put a range here A to F. I'm going to just run like this. For example, I'm going to say something called 1 to 10 and I'm going to put a name called like this. So you can see this. Can you see this? This is the
Let me ask you
information
a
how.
question regarding this star one.
Mm-hmm.
Can I put ls etc aura star so that can I get everything like aura 1, aura 2, aura 3 star after the file name or directory name?
No, I didn't get you. Please come again.
Over here we have seen the example like star.
Yes, okay, I got you.
Okay.
So you're going to say like this. Yes, it will give you.
Aura all everything. Yeah.
Yes, anything it will give you. I'm just giving you an other extension, the end of the extension. You can put anything here. For example, I will just say not only Aura, I will just build D star. I'm going to list whatever the file or directory, whatever it is. It starts with D. I want to know this information.
Okay. Okay.
Okay. Not only like that, you can also put like this also star R star.
Okay.
In between, it should be R, which is going to match R.
Okay.
It may start with any name. It may end with any name. Okay. So this is the way how it is going to work. Yeah, right.
Yeah. Yeah. That's fine.
Okay, so this is how the wildcard characters are going to work, and the star we regularly use, and this all wildcard characters are very effectively used when you are writing some kind of script. Okay, so when you're writing some sort of scriptings, we will be using this.
So we got only these three.
Yes. Okay,
Okay.
getting it. So right now we are just at the basic part. We are just discussing about only this things. Okay, and now when we talk about the FAP, it is called file access permission. So when I'm talking about the file access permission, so basically from the first day we are discussing about security, right? So basically there are so many types of securities. Right now we are just concentrating on the basic level security. Okay, So when I talk about basic level securities, we have two types of securities here. One is login level and second one is FAP. Okay, so when I say login level, that is nothing but already we discussed. Whenever you want to log into the Windows or Linux, you need to put username and password. But when it comes to the Windows, the password screen will be shown with some special characters. With this, a person who is sitting behind you or beside you, they can just analyze if there is 6 asterisks. He will understand that it is a 6-character password, and he will try to guess, and one or one other way he will try to crack it. Okay, but when it comes to the Linux or Unix, the password screen will be a blank screen. Getting it? So there is no scope of knowing what is the length and strength of the password. And we have something called FAP. FAP stands for File Access Permission. So when I say File Access Permission, so you should understand one thing. So every file will have permissions like read, write, and execute permissions will be there. And we are going to discuss how these permissions are allocated to the files and directories. Okay, so now we are going to see whenever we create a file or directory, it assigns a permission tag to the file or directories. But here the question raises, how do we know about this permission? So we are going to know about these permissions when we run ls-l command. When we are running ls-l command, so it is going to give you long listing with 9 field output, and in this 9 field output we have the first field is permissions, where the first field is something called permissions, right? So when I talk about the permissions, now we are going to discuss that these permissions are divided into totally 10 fields. Okay, so we are going to discuss about each and every field here. The first field indicates the type of a file or a directory. It indicates type of the file or a directory. So hyphen indicates all was normal file, D indicates the directory file, L indicates the link file, C indicates the character file, B indicates the block file, and when I talk about star and till, it is going to give us information that it is an executable file and the backup file. And you remember one thing, the star and till you're going to see after the file name but not with the permissions. Okay, after the name, if you see star, it is nothing but executable file. After the name, if you see till, it is called backup file.
Okay, what is the?
And remember one thing.
Let me ask.
Yes, tell me.
What about what is this C character file and block files?
That is a device files, right? As we discussed at the beginning of the session, the previous sessions, like even in Linux and Unix, everything is treated as a file. File is treated as a file, directory is treated as a file, even device is also treated as a file.
Like if we put any pen drive
Right?
to that, it will. It is
Yes, that's what. Not only pen drive, your processor, memory, disk, printer, scanner, tape drive. Okay. Basically, the devices are divided. The devices, okay, whatever devices you are connecting to your machine, they're divided into two categories. One is block devices, another one is character devices.
okay.
Okay, like keyboard, mouse, printer, this all comes under character. Disk, DVD-ROM, tape drive, logical volumes, this all comes under block devices.
Okay, that's fine. Yeah.
Understand?
Yeah.
So this devices files are located in /dev directories. So when you go to the /dev, you will find this information. So you can just get into the /dev here. So when I just say /dev here, when I say ls, this is all the things. Okay, now when I say ls-l here, you will see there's something saying character and block. You can see root and disk, it is saying. Disk is nothing but block. Understand? TTY, that is called terminal type. What is terminal type? Right now we connected to the server. Using which terminal we have connected? You have to say TTY, you will come to know which terminal we have connected. So you can know this. Terminal or character, because we run a command ls, it will take ls. ls, this is characters, not as a block. Okay, so this is the information. Now, and second, third, fourth, field indicates the owner permission. And basically I'm not giving the values of this 2 3 4, I'm just representing it will be read, write and execute. And 5 6 7 is the group permission, it represents read, write, execute, and 8 9 10 is nothing but others, it is also representing read, write, execute. Okay, and you know, as we discussed, whenever you're creating a file, by default you will have this permission. Okay, now let me give you a detailed information how these permissions are going to work. So take an example inside the operating system. I'm taking example about 3 groups. I'm taking an example of 3 groups here. So when I'm talking about 3 groups here, like we have an operating system, and below this operating system we have a groups like Unix, we have a group called Java, we have a group called Oracle. And you know, every group is having some users. So Unix is having U1, U2 and U3, and the Java is having J1, J2 and J3, and Oracle is having Ora1, Ora2 and Ora3. Like this we're going to have. And when I'm talking about, this is the information. Okay, and basically there is a user with the name called U1. And this U1 user is creating a file here with the name called something called file1. So basically, who will be the owner of this particular file1? So the owner of this file1 will be U1. Okay, I can say U1 is nothing but owner. Okay, or the owner is also called user. Right. Now, who all comes under group people? Including U1, the people whoever they belongs to this Unix group all comes under group members. So this all comes under group members. And who all will come under others? Apart from Unix group, we have a Java and Oracle or any other group. Apart from Unix, you're going to see here on the machine, they all come under others. Understand? And you know, whenever you are creating a file, by default, I'm just talking about the root level. On the root level, when you're creating a file, the permission, file permission is 644. So when I say 644, the first 6 is for owner. Second, the 4 is for group, and this is for other. This is the thing. Okay, but when I talk about directory, what will be the permission? So permission on directory when I talk, okay, so dir permission, when I say the permission is 755. So when I say the 755, the first one is owner, sorry, and this is for group, and this is for others. Getting it? But this is, I'm just talking at the root level. So why specifically I'm telling you at the root level? What about user level? What happens in user level? So when I talk about users level, user is nothing but normal user, remember. When I talk about normal user, what happens? If I'm creating a file permission, it will be 664. So 664, the first 6 is for owner, it is for group, and this is for other. Okay, so why in the Linux, why the user is getting this typical permission? Why not as same as root? Why it is showing difference between root and normal user? Because when you are creating a user in the Linux, for example, I'm creating a user called Sam. He is a user and he belongs to his own group called Sam. So if I'm giving a permission to the owner, I mean, if a system is giving a full permission to the owner, if it is giving to the group, it is same. Okay, that is the reason the permission is like this. And when I'm talking about the directory, 1 minute, give me 1 minute, I'm getting a call. So when I'm talking about directory permissions, so here it will be something like 775. So here the first 7 is for owner permission. This 7 is for group, and this is for other. Okay, so this is the way how it is going to work. Is this clear? Any doubts here?
No, it's fine. Yeah.
So I have just given you the information, but you should also know why I'm getting like this. Okay, I know that because I told you that user when I'm creating a user, he belongs to his own group. But okay, good, fine. But still he belongs to the own group. Is it mandatory that I should give a full permission to the group? No, right?
No.
Yes or no?
No.
But still why it is giving? Still why? Because when I talk about root, for example, when I'm talking about root, even root belongs to his own group only. That is called root only. Root is a user, root is a group. But here the problem is, in this root group, not only root, there are so many other users who belongs to the root group. If I am giving permission to the root group, that means whoever the users they belongs to the root group, they all get the same permissions. So that means they are misusing the permission, right? Yes or no? So that's the reason we will not give such a kind of. So I will give you more information about that, why it is happening like this. Okay, now what we are going to do is, so the things, and U stands for user, and G stands for group, and O stands for other. These are all the symbols that is used for the user, group, and others. And when we talk about permissions can be assigned in two methods. One is character method, and another one is numeric method. So when I talk about character method, the permissions, read is always identified by R, write is always identified by W, and execute is always identified by X. Understand? And the permissions in numeric method, so always read has a numeric value called 4, write has a numeric value called 2, and execute is having a numeric value called 1. Altogether it is 7 permission. Okay, so this is the things how it is going to work. And permissions on the file level. If a file is having read permission, what we can do? If a file is having the write permission, what we can do? If a file is having a execute permission, what we can do? We're going to discuss. So when I say the file has a read permission, we can read information related to the file. You can read information related to the file, and W is nothing but write. We can edit and insert and delete the information from the file. Information is nothing but data. Okay, and when we talk about execute, so if you want to run any file as a script or a program, we will give execute permission. And you know, every file is not required execute permission. Okay, if you get an information boss, this file need to be executed as a program, then we provide execute permission to that file manually, and we will allow that to run as a program. Otherwise, not required. And when we are discussing about permission at the directory level, so directory has a read permission. That means inside the directory you have some files, and some directories you can list their names. Okay, and W is nothing but write. We can create a file or directory inside the directory if you have a write permission. And X is nothing but you're going to use CD command to get into the directory. For that we are going to use CD command. And you remember, if you don't have a directory, if a directory is not having X permission, that is called execute permission, you can't do CD into the directory. Remember that. Okay,
For
so this is
almost,
all. Yes.
for almost every directory, we will be having this execute permission, right?
By default.
By default.
By default. Not only for owner, it will be there for group and others also.
Others as well, yeah.
That's the reason I'm telling you 755.
Yeah, okay.
So 7 means read, write, execute. 5 means read and execute. 5 means read and execute. I'm telling you by default it will be there.
Okay.
Okay. So we are not going to assign it. It will be there by default. Okay. So this is the thing. And when we talk about a file, basically file will have two types of permission. One is default, another one is maximum. So basically, what is the default permission for a file? It is 644. This is at the root level. When I talk about user level, it will be 664. Okay, and maximum permission for file is 666. That means owner, group, and others are having full permissions. Okay, and the default permissions for a directory is 755, and the maximum permission for directory is 777. This is the information. Right now, from my side, it's a question to you. Why, when we are creating a file or directory, why it is giving me default permission? Why not maximum permission? What is the reason?
So if we do like that, all the group and others may change the data in the directory.
Okay, okay, fine. So you are saying for security reasons,
Security, security.
right? Right. But who is going to give, who is going to provide this default permissions? Why not? Who is going to hide these permissions? You know, when you see for a directory, it is hiding a right permission for group and others. When you see for a file also, even there also it is hiding the right permission for group and others only. So who is hiding that? Are we going to hide it or system is going to hide it? If system is going to hide it, and using what value it is going to hide that? Is there any specific value to hide that?
Mm, no idea.
No idea. So how then? How it is going to happen? So basically on the server there is a value with the name called umask value.
UMask.
Umask. So basically this umask value will be hiding this permissions. That is a reason whenever you are creating a file, it will take the full permission. From that full permission, it will minus the umask value and it will provide the default permissions. It will provide the default permissions. Getting it? So this is the way how it is going to work. Clear? Understood? So this is all the information. But how do we see that umask value? There is a command with the name called umask command. With the help of umask command, you can see the umask value. But you know, right now we logged in as a user. The umask value is 0002. Actually, don't consider first zero. That is a special permission that is called set UID, set GUID, ACLs. That is called. You have to only see this permission that is called 002. Okay, okay, that is a special permissions called set UID, set GUID, sticky bit that we will be seeing in administration. Leave it about that. We are just going to discuss the 202. Okay, for example, when I go to the root, what happens? I'm going to the root. What will be the umask value? So when I say umask, you can see it is totally different. Okay, so this is the differences that you're going to find between the root and the normal user. Okay, and umask is a command. Not only is the umask value, we can change the umask value. And when you are changing the umask value with umask command, it is only used to change for temporary purpose, not for permanent. You can see right now I changed it. If you want to still tight the security on your file or directory, you can put like this. Understand? So this is the way. So what is this permission? For example, I'm having full permission for directory -027. What will be the permission here? 750. That means owner is having full permission, group is having read and execute, others no permission. Understand? So this is the way how it is going to work. Understood, right? Any doubts? So I'm just telling it for a directory. If I talk about a file has 666 full permission -027. What is the permission here? That is nothing but 6 4
Minuses.
0.
Okay.
0 is nothing but minus only.
Okay.
Okay, 0 is nothing but no permission. So owner is having read write and group is having read, others no permission. So when you will type this kind of securities, so for example, you're working in finance department, you're working with some HR department, you're working with some other department, and your manager or your client will say that this group information should not be seen by other groups. Whatever the file or directories, whatever the quotations you're going to prepare it should be only with you and with your group people. Sometimes your client will say, your management will say that if I am configuring some quotation that should be viewed by me only. Then at that time what I will do, the UMass value I am going to set as 077. What it will do, 077 means it is going to give only permission to the owner, not for group, not for others.
Yeah.
Okay, and you should remember one thing, we are going to customize the UMass value when, okay, you are going to create or your group people are going to create huge number of files and directories, and we will first change the UMass value and then we will just allow them to create, because when they start creating a file or directory, it minuses from the UMass value and it will allocate the permissions to the file and directories. Understand? So this is the way how it is going to work. Then understand. So this is the thing, and you have to remember another one thing. Once you change the UMass value, that is going to reflect the current files and directories that we are going to create, not the previous files and directories that is already created before you change the UMass value.
Okay.
Done.
Yeah.
So this is the information. But when we change the UMass value, is it permanent on your machine?
No.
No, it is only temporary purpose. If you just log out from this machine as a user and again you connect, it will come to the default. Default means this is a default. It is called 0002. Okay. If you want to make it permanent, what we have to do? So when I say ls-a command, you see there is a file with the name called .bashrc. Can you see this? Open this particular file and put umask is equals to 027, and afterwards once you log out and log in to the machine, okay, because these are initialization files, it will get executed when you log off and log in only. So when you log off and log in when into the machine, so the UMass value instead of showing 0002, it will show you 0027. This is how it is going to maintain. We're going to make it permanent. But I am going to show you here the UMass value permanent only for a user. But if you want to do it on the root level, then what we have to do? On the root also, when you just switch to the root, on the root also same kind of files you're going to see, and that file is located here. In etc it is located, not as is hidden. When you just open this particular file, you can see the UMass value here. This is allocated to the user and this is, so you can change it here. So whenever you are creating a user, it will be allocated to the user. So this is the way how it is going to work. Okay, getting it. This is all the information. Any doubts here still? Yes,
It's clear.
it's clear, right? So this is the information how we are going to work. So now let me give you the information. So you have understood how to change, how to make it, and now we are going to discuss, we can change the permissions in three methods, that is before creating a file or directory, while creating a directory, and after creating a file or directory. So already we discussed before creating a file or directory by customizing the UMass value. So when you are customizing the UMass value, it is going to do this, and while creating a directory, this is a syntax. So mkdir-m followed by the permissions followed by the directory name. And chmod is nothing but once already the file is there, once already the directory is there, we can use chmod command to change the permission. Okay, so I will just show you from the second method because already we have seen how to change the UMask value. And I mean, of course, after changing UMask value, hello.
Yeah, it's connection been lost. Sorry.
Yeah. Okay. Now you're able to hear me, right?
I can, yeah.
Yeah. So I'm just giving you the information. How do we use mkdir command to cu customize the permissions for a directory while creating? Okay, so this is the thing. And after creating, when I say after creating, you have to use chmod command. There is no other way. But when you're using chmod command, we discussed that permissions can be changed uh, in two methods. One is numeric method, another is character method. Numeric means read is identified by 4, write is identified by 2, and execute is identified by 1. So altogether it is 7 permissions. So we are going to see how we are going to do it here. Okay, so what we are going to do here, so we are going to just run chmod command, but before we run chmod command, I'm going to show you the directory. It is full permission and chmod 700 followed by dir 200. So what we are doing here, I'm just removing the permissions for group and others. So if you want to allocate the permission here, it should be 5. This is the way how it is going to work. Clear, right? So this is the information how it is going to work.
Yeah.
Clear. So whatever the permissions, based on that you have to give. I'm just giving an example here how to remove and how to assign. For example, like I get a permission saying that I have to give only permission like this. Yes, you can do it. Okay, you have to look here. This is a permission for owner, this is group, and the rest of the thing is others. This is the thing. So this is the way how do we assign in numeric method. Now I'm talking about character. So you should remember these symbols to work with character. U means user, G stands for group, O stands for others, R stands for read, P stands for write, X stands for execute, plus is nothing but adding the permission, minus is nothing but subtracting. So when I talk about this, so I'm going to show you this chmod. Okay, I want to give a permissions to the others, read and execute permission. So O stands for others, and I'm going to add the permissions like read and execute for dir 200. This is the information. So this is the information how it is going to work. Clear? Understood? So this is the way.
Yeah, it's
Understand? Okay. So this is how it is going to work. If you want to remove these permissions, then I'm going to put minus. This is the way how it is going to work.
yeah.
Right? Understood?
Yeah.
So this is the way how it is going to work. Right?
Yeah.
And like for example, you have a different requirement here. Assume that already the owner is having read and execute permission, read and execute permission. So my requirement is we have to remove write permission for owner, and I want to allocate read and execute permission for others. Take an example. I'm telling you, we will not do like that for any directory or any file for owner. So I'm just giving you chmod.
Mod.
Okay. Or else what we will do is I will try to add a permission for others right now. I have added a write permissions, execute, read and execute permissions for others. Can you see this?
Yeah.
Now what is my requirement is for a group I want to allocate write permission, and for others I want to remove this read and execute permission. So what I will do chmod
Plus
group
W.
plus w, and for others o minus
Read and write. Yeah.
this is the way
Okay.
it is going to work. So this is all the information how it is going to work. And right now I'm going to show you how to change the ownership and groupship of the file. So when I talk about ownership, for example, I am going to switch to the root. I'm going to switch to the root when I say ls-l command. You see there is a file with the name called anaconda-ks.cfg file, and the owner of this particular file is root, and the group is also a root, right? Now I want to change the ownership because I don't want to give a ownership to the root. I want to give ownership to the user called Kumar. So what I will do, chown own AUMA Kumar followed by anaconda hyphen. Now when I say ls-l, the ownership for this particular file is Kumar. And what is the ownership permission here? Because the Kumar is having a read, right? So he can just log in as a Kumar user and he can just access this file and he can modify it. Okay. Now if you want to change it for a group, using chown command, you can change it for owner as well as group also. For example, we have install log. For that, owner is root and group is also root. So chown own. So Kumar install log. Now this is how it is going to work. Can you see this? But still there is a specific command to change the group shift. For example, right now the group shift for this alias Kumar, I want to change it to the root chgrp dedicated command. So this is the information. Clear?
Yeah.
So this is all the way how it is going to work. Understood, right?
So
So with this, we have done with the permissions,
okay, let me.
ownership change. Yeah.
So we added and subtracted the read write for the users and others. So whatever this equal to.
Equal to means adding them equally.
So equal to, then if we have, can we see one example on that?
Equal, equal permissions if you want to add. So what is this equal permission? For example, ls-ld dir 100. This is a permission, right? chmod. Okay. So I want to give equal permissions to all. So um, do is so user group others equal read
Right.
execute. Here. You see this?
Okay. RX.
Hmm?
Yeah.
Getting it? If I say now, this is it.
Okay.
Hmm?
But
So this
numerical
is the
is
way how.
easier, I think.
Uh,
Numerical permissions.
this is only for symbolic method we are discussing, not for numeric, right?
Yeah, but it, I think
How you do
in real time
it is only for
understanding.
real time. I mean real time understanding. You're saying then you have to use like this chmod. For example,
So, yeah.
5 for dir. Sorry, dir 100.
Okay.
Understand?
Yeah.
What is the way? So with this, we have completed this securities that is called FAP, and we're going to stop here. We have to start a big concept called VI, VI editor. So it takes nearly 1 hour. So I'm not going to start anything right now VI editor. So you practice this VI editor. We will be starting tomorrow. Once the VI editor is completed, so we will be going with some other basic concepts what we have. So already we discussed the zip commands right yesterday only. No need to give any information.
Yeah.
Okay. So this is all about today's session. Okay.
Okay. So can
Fine.
any material, as you said, you provide a material for all this.
Okay, I will send you this files. 1 minute. Be online.
Okay.
Can stop recording also.
Yeah.